Good morning, friends. Myself Devraye-Patil, Head Department of Chemistry, late Ramesh Varpudkar, College Sonpet. Today we will discuss the unit first, atomic structure and wave mechanics. In that, we studied the Planck's quantum theory, photoelectric effect, Compton effect, de Broglie hypothesis, Davison-Germer experiment, Heisenberg uncertainty principle, Schrödinger wave equation, and numerically based on de Broglie's equation. In that, we studied the wave nature of light, which helps to understand the formation of chemical bonding and the electronic structure of atom. The waves are the oscillation in the matter. Light is an electromagnetic waves consisting of oscillations in electric and magnetic field traveling through the space. Each wave are characterized by wavelength and frequency. Wavelength is the distance between two adjacent crust and trough shown in the figure. Let we see the electromagnetic radiations. We know the wave characterized by frequency and wavelength. Frequency denoted by nu and wavelength denoted by lambda. Units of its cycle per second or hertz. The units of wavelength is nanometer. The relation between wavelength and frequency shown in the equation, where c is the velocity of light and it is 3 into 10 to the power 8 meter per second. From this relation, it is clear that the frequency and the wavelength are inversely proportional to each other. As frequency increases, wavelength decreases. Here, as the wavelength reduced by 2 factors, then frequency increases by 2 factors. Let we see the numericals based on this relation. What is the wavelength of blue light with frequency 6.4 into 10 to the power 14 per second? The wavelength obtained is 4.7 into 10 to the power minus 7 meter. As like we calculate the frequency from this relation. The scientist Max Planck said that the object or corpuscles gain or lose energy by absorbing or emitting radiant energy in the form of quanta. That is, Max Planck said the light are particles. The particles absorb or release their energy in the form of radiation, and this radiation emits their energy in the form of quanta, that is energy bundles. He gives the relation between energy and the frequency, which is energy proportional to the frequency, that is E is equal to h nu, where E is the energy and nu is the frequency and h is the Planck constant. As lambda increases, the energy decreases, that is energy and the wavelength are inversely proportional to each other. The photoelectric effect, that is the ejection of electron from metal surface when light strike on it, that is electron For ejection of electron, it needs minimum amount of energy, and that energy measured in the frequency, and that frequency is called threshold frequency. For example, violet light can cause ejection of electrons from potassium, but the red light have no any effect due to red light have lower frequency than the violet light. The scientist Albert Einstein worked on the idea of Planck. Einstein observed the energy of photon is proportional to the observed frequency of light, and therefore it uses the relation of photoelectric effect and relation of Planck's. Here is the schematic diagram of photoelectric effect, where light rays strike on the metal surface, where the metal electrons absorb energy in the form of photon and excited to higher energy level and eject from the metal surface and travels towards the positive plate. In this way, electrons are travel from positive plate to negative plate. Here, Einstein assumed that an electron is ejected when struck by a single photon, which behaves like a particle. Photon hits metal, its energy is h nu, taken by the electrons and excited to higher energy level and eject from the metal surface, where wave and particle of light should be regarded as a complementary view of the same physical entity, and it is called wave particle duality of light, and give the equation E is equal to h nu, where E is the energy of photon and nu is the frequency of associated wave. Where here Einstein says that metal requires certain amount of energy to eject electrons, and it is called work function. Since photons have energy E is equal to h nu, and for ejection of electron it requires more frequency than the work function shows in the figure. In this, Einstein demonstrated this figure. In this figure, it is clear that there is no any electrons are ejected whenever the certain amount minimum energy is used by this ejected electron. The number of electrons ejected does not depend on the frequency, rather it depends on the intensity of light. That means the total frequency of light is not depending or not required for the ejection of light. It requires only the electrons are grows from lower energy level to the higher energy level. Let me see a video of explaining the photoelectric effect.
You see this setup on the screen? This is meant for an experimental study of the photoelectric effect. I hope you have some idea of the photoelectric effect. Now, as you can see, it has an evacuated glass or a quartz tube having a photosensitive plate. Let me label it as C. Now, this is known as emitter. And there is another metal plate A, which is known as the collector. Now, as you can see, the emitter and collector are attached to a battery that maintains potential difference between the plates. And you see that? There is a small window that opens up into the glass tube. It's a transparent quartz window which permits ultraviolet radiation to pass through it and irradiate the emitter. Now, monochromatic light from a source of a sufficiently short wavelength passes through this window and falls on the photosensitive plate, that is C. Now, because of photoelectric effect, the electrons are emitted by the plate C and are collected by the plate A, which, as I told you, is known as a collector. And why does it happen? By the electric field created by the battery. Now, when the collector plate A is positive with respect to the emitter plate, that is C, the electrons obviously are attracted to it. The emission of electrons causes a flow of electric current in the circuit. The resulting photocurrent that is flowing in the circuit has to be measured. And that's why you have that microemitter there. The photoelectric current can be increased or decreased by varying the potential of collector plate with respect to the emitter plate. The intensity and the frequency of the incident light also can be varied, and as can the potential difference V between the emitter and the collector.
So from this video, we will get the idea about photoelectric effect. Tomorrow we will see the next point. Here some tricks to remember the uh, elements from periodic table. So look at this, and thanks for watching this video.